Okay, 3.1 is going to begin really the main sort of mathematics that we're going to want to capture in this course. And it's going to expand on what we've already been talking about, and that is the normal curve. So we care about our histograms, and then we care about the shape of the histograms, and we want that shape to be symmetric normal. Because if it is, then we can do all sorts of predictive statistics on that sort of data. Okay, so there's only two things we need to know about the normal curve. One is, where is the hump, the center? And then two, how wide is it? Now, in section 3.1, the entire section is going to be, how do we find this hump? So we call this section measures of center. So where is this center? And then in section 3.2, we'll study how to calculate the width of it. Okay, there's 5 different methods to calculate this center. So we will look at mid-range. We'll look at mean, which you probably heard called average. We'll look at median, mode, and then weighted mean. So those are the 5 that we will look at in this course. And they're pretty simple. So let's get some equations to figure out how to calculate these things. So let's start with mid-range. So mid-range, to calculate this value, it's equal to, you just take the maximum value in your data. So you have a list of numbers, take the biggest number, add to that the smallest number in your list, and then divide by 2. So you take the biggest number, smallest number, add them up, divide by 2. Okay, pretty simple. Let's look at mean. Mean is equal to the summation as I goes from 1 to n, x sub I divided by n. Now that is shorthand mathematical language. This is a summation symbol. It just means add up a bunch of stuff. So in this course, I'm not overly interested in you knowing what these symbols are, what they mean. So let's make it a little simpler for us. This says xi, where I starts at 1 and goes to n. So n is the number of data points we have. So what this really says is just add up all your data. Take x1 plus x2 plus x3 plus dot, dot, dot. This means the pattern continues, plus xn, which would be your last data point, and then just divide by how many data points you have. So you all know how to do this. You've been doing it probably since grade school, maybe even, or certainly since high school. Calculate an average, add up everything, divide by how many things you have. That's all it is. Okay, let's look at median next. I would guess you've all probably heard of this or done this one as well. So the median is just equal to the middle number when your list, and this is important, when your list of numbers is ordered from smallest to biggest. That's the most important step. If you skip that step, you're going to get it wrong. So the first thing is you order your numbers from smallest to biggest. And then it's the middle number, so there'll be an exact middle number if n, the number of data points you have, is odd. You're going to add the middle two numbers and divide by 2 if n is even. And we'll see examples of both. So if your list is an odd number of things, there will be an exact middle number. You'll just circle it. If you have an even number of things, like 10 or 20 numbers, then you have two middle numbers that you'll add and divide by 2. Okay. Mode is equal to the most frequent value or values. So you can have more than one mode, but it's just, is there a number that keeps repeating? So do you see a number 3 times or 4 times or 5 times? So if you see one number that's repeated a bunch of times, that's called the mode. Sure.
What if you have several modes that
Perfect question. So the question is, what happens if you have more than one number that's repeated? So I think we'll see an example of this. Let's say you have 2 numbers that each appear 3 times. Then you take both numbers. Let's say you have one number that shows up 4 times and another number that shows up 3 times. You take the number that shows up 4 times. So you take the one that shows up the most. If there's a tie, you take both. There could be a 3-way tie or a 4-way tie. You take all 4. Okay. Yeah, so you can have a lot of modes. Okay, the last one is called the weighted mean. Weighted mean. And again, I'm going to give you the mathematical shorthand. So it's the summation. So we're adding up a bunch of stuff again. I, which is just an index, goes from 1 to n. So I have n numbers. And it's going to be xi again. So far it's the exact same as the mean. But now we're going to multiply each x by a weight. And then we're going to divide by the summation of the weights. I goes from 1 to n. But let's write this in simpler form. So what does this mean, these summations? It just means you're adding up a bunch of stuff. So I take xi times wi, and we're going to replace these i's with 1, then 2, then 3, etc. So it'd be x1 times weight 1 plus x2 times weight 2 plus ... pattern repeats, xn, the last number in your list, times weight n, all divided by the sum of the weights are just these w's. So w1 plus w2 plus ... plus wn. We'll see an example on how to do this one because it's a little tricky. This is how you calculate GPA, right? So I take a 4 credit hour course, I get an A in it. I take a 3 credit hour course, I get a B in it. Those credit hours are your weights, and then the X's are your A, B, C, or D, right? So we'll see how to do that. So it is useful. Questions on these? So these are all the tools we're going to use today and going forward. So now you're starting to see we're getting into a little more math. But it's still, at this point, just addition, multiplication, and division. So it's not terribly complicated, hopefully. Okay, so let's look at the first problem. This one says A magazine published a list consisting of the state tax on each gallon of gas. If we add the 50 state tax amounts and then divide by 50, we get 27.3 cents. So if they add up all the numbers and divide by how many numbers they have, they just calculated a mean, right? They added up all their numbers and divided by how many numbers they had. Is the value of 27.3 cents the mean amount of state sales tax paid by all U.S. drivers? Why or why not? Why do you say no? So you're absolutely correct, and I applaud you because this question is tricky. Because on the face of it, you say, oh, I want to find a mean, just add it up, divide by 50, right? But you're absolutely right. This has to be a weighted mean. So a mean won't cut it here. We need a weighted mean. Why? Because you said it already as well. Not every state is equal as far as size, population, gas consumption, those sorts of things. So if you start talking the U.S. and you want to start comparing apples to apples with states and things, you need to account for the fact that each state is different in size or consumption. So is this the right way to go? The answer is no. So let's get these yeses out of here. The value 27.3 is not the mean because it is the median. No, it's not the median. They didn't list things in order and then find the middle number. No, the value is not the mean because the 50 amounts are all weighted equally in the calculation, but some states consume more gas than others, so the mean should be used a weighted. That one you have to think outside the box a little bit to bite on the right answer. Okay, 2. Okay, so this is good practice calculating these. We'll find the mean, median, mode, mid-range for these for this list of data. So we have the weights in pounds of 11 players randomly selected from the roster of a championship sports team. Are the results likely to be representative of all players in the sports league? So first, let's identify n, the sample size. N is equal to 11. Now, should that number give us concern? Yeah, so it's less than 30, so we should be concerned. Now, we're still going to continue because they're doing you a favor. Okay, if they gave you 30 numbers, you would have to add up all 30, divide by 30. It's a lot of work. So in these kind of problems where we're just practicing the math, it's okay to have a sample size less than 30. So find the mean. The mean, which we'll also use X bar as a symbol. I should have written that back here. Mean, we'll use the symbol X bar. Mid-range we'll sometimes call MR. Median, I've not really seen a symbol used for that typically. Mode, also no. And then weighted mean we'll just call WM. So we don't have a lot of symbols to shortcut these, but we will if we can. X bar is very common though, so we'll see that a lot. X bar is the mean. And for this problem, we just add up our 11 numbers. So it'd be 241 plus 233 plus ... Pattern continues until 301. So I'm not going to write them all down. In fact, on a test, you would not have to write them all down either. Just show me you know what you're doing. Here's the pattern. Divide by 11. And then if you add up all those numbers correctly, you should get 2905 on top. Divide by 11, 264.09. And I believe they want us to round to 1 decimal. So this 9 will kick this 0 up into a 1. 264.1. Okay, part B says find the median. Well, to find the median, first put in order. Small to big. So you go through your list, and I like to write it right above these numbers so I know I get all of them. So the smallest number would be 180, so that should be right here, the first number. Then the next smallest, I'm just going to look here, I think is 233. Then 241, 248. Then it looks like another 248. Then I'm showing 257 if I didn't miss one. 289. 2 301s. A 303. And a 304 if I didn't make a mistake. Now, because n is 11, that's odd. There should be exactly one middle number. And if you divide 11 by 2, you can get a sense of where that middle number would sit. So 11 divided by 2 is 5.5. So it should be 5 numbers from the left. 1, 2, 3, 4, 5. 5 numbers from the right. 1, 2, 3, 4, 5. And that should sandwich the exact middle number, which is 257. Is everyone okay with how I did that? Put them in order. Divide this by 2 to get a sense for where the middle number sits. And then just count from the left and right. So 257. The next part says find the mode or modes, plural. Well, if we put them in order, it's also easy to see the mode. So I go through here, and I see that I've got 2 248s, and then we've got 2 301s. So my highest repetition value is 2, and I've got 2 numbers. So because they both share the same number of repetitions, we'll take them both. So we'll say 248, comma, 301. If no number is repeated, then you'd say I don't have a mode. There is no mode. Mid-range. Mid-range was take your maximum number plus your minimum number, divide by 2. So again, having them in order makes it easy. Your biggest number is 304. Your smallest number is 180. That's 484. When you add those two, divide by 2, 242. That's exactly right, 242. Now, these are all supposed to be measuring the same thing, the center of these numbers, the hump of the normal curve. So you should kind of see, are these numbers pretty close? 260, 260, 250, 250-ish. So they're pretty close to 250, 60. This mode's a little high, right? But they should be kind of in the same ballpark. Okay, the last question. Are the results likely to be representative of all players in the sports league? So they literally took the championship team, grabbed 11 people from it, and took their weight. Is that representative of the entire league? No, exactly. What would be a better way to get a sample of the entire league? You'd want to randomly sample a few members from every team, right? That'd be a better way to do it. So the results are not likely to be representative because the championship team may not be representative of the entire league. In fact, there's a good chance it's not because it's the championship team, which means they probably have the best players. Okay, let's look at B. The results are not likely to be represented because the median is not equal to the mean. This will almost never happen. So that's not a problem. The results are not likely to be represented because the median is not equal to the mode. That also will almost never happen. These numbers don't have to be equal. They should be probably close, but they don't have to be equal. Okay, problem 3 is exactly the same, pretty much. Listed below are the measured radiation emissions in watts per kilogram corresponding to cell phones. The media often present reports about the dangers of cell phone radiation as a cause of cancer. Cell phone radiation must be 1.6 watts per kilogram or less. Find mean, median, mode, mid-range, all those things. Let's first find out how many numbers we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh, I was hoping to be even. Well, it's odd again, so it'll be simple. If the number is odd, then we have exactly one middle number. So that makes the median calculation pretty simple. Find the mean. So again, X bar. Add these numbers up. And again, I'll just show the pattern. First two, ... plus the last one, divided by 11. And if you do that, you will get exactly 9 over 11, which is 0.818. It's actually 0.81818. It just keeps repeating. And to round to 3 decimals, so to 3 decimals, we're at the third spot. We look to the right, it's 1, which is less than 5, so we just dump these. So we'd call it 0.818. The median, we'll have to put these numbers in order. If we do that, it should be 0.41 first, then 0.44, 0.45, 0.48, 54, 68, 92, 94, 1.14, 147, and 153. So those are now in order. Just like before, if n is 11, that means we'd have to go 5 and 5 from each side. 3, 4. So there's 5. And here's going to be the other 5, which means the middle number is right here between those two, 0.68. Mid-range, take the biggest number plus the smallest number, add them up, divide by 2. 153 plus this 0.41. If you do that, you'll get 0.97. What about the mode? Yeah, so do we see any number repeated at all? No, so they're all different numbers, so there is no mode. There were no repetitions. Okay, last question. If you are planning to purchase a cell phone, are any of the measures of center the most important statistic? Is there another statistic that is most relevant? If so, which one? So the whole point of this is to find out, hey, are my cell phones getting close to this 1.6 number? Because if they're close to that number, then the science says, be careful, that can cause cancer, that amount of energy density, okay? Well, all of our middle numbers are pretty far away from that, right? So this is literally half of that number. This is less than half of that number. This is just above half of that number. So our measures of center don't seem to give us any concern about cell phone energy. But look at the maximum number. That's kind of close, isn't it? So I might want to find out who makes that phone and avoid it, because it's just a little too close for comfort maybe. And what do we call this number? That number is the max. So our measures of center don't really apply to this concern, but our maximum does. So the maximum data value is the most relevant statistic because it's closest to the limit of 1.6, and that cell phone should be avoided. Perfectly worded. A. Questions on these types of problems? Should be hopefully pretty straightforward when you do them on your homework. Now, in a problem like 4, if you add up, so let's read it. Listed below are pulse rates, beats per minute, from samples of adult males and females. Find the mean, median for each of the 2 samples, and then compare the 2 sets of results. Does there appear to be a difference? If you add up these numbers, you find out there's 15 men and 15 women. That is too many numbers to do by hand, okay? You do not want to do this problem by hand. So I'm going to give you the steps for which you would do this on the computer, and then the computer will just spit out the answers that you can record. So here we go. Okay, so in this problem, you'll see a little button or icon. It looks like a window inside a window, and that's going to load up this data. Actually, it's not going to load up this data. This symbol will be near this data, and you'll click it, and then you'll say, open in StatCrunch. Okay. Then there'll be a button in StatCrunch called Stat. You'll click that, and then there'll be a drop down, and from that you will select Summary Stats. And then you will click Columns, because your data will appear as columns. So when you open this in StatCrunch, these 15 numbers will be vertical in column 1, and then these 15 numbers will be vertical in column 2. And then you're going to click variable 1, and then you're going to click variable 2. So you're going to load both of those columns into the program. And then you're going to click compute at the bottom. Compute. And actually, you could use those steps on those previous 2 problems we just did. And then you wouldn't have to do those by hand either. And you'll also use these steps for problem 5. So these steps could save you a lot of effort because the computer will do the crunching for you. You might want to do a few of the smaller problems by hand just to get practice. But if you do these steps, you will get the following numbers. So the mean for males is 66.5. And the mean for females is 78.3. And then you'll get the median for men, 63. Now be careful, of course, your problem, these numbers might be different, so read it from the chart. These steps will produce a table, and it's pretty clear. They label it nicely. They all have column headings that will say mean and median. Just read the numbers off. Then this is 79 for the median for the females. Now this is the more important part. Okay, getting a number is fine, but the more important part is, what does the number tell us? What can we learn from this? Well, just looking at these numbers, the two middle values for men are around 65-ish, and the numbers for women are almost up to 80. Do you see how the women's heartbeat numbers are almost 15 beats higher than the men on average? That's a pretty big, significant difference, okay? So what we would say is, the mean and median appear to be the same for both genders. No, it's clear that the female numbers are higher. The mean and the median for males are both lower than the mean and the median for females. That's true. Does there appear to be a difference? So the pulse rates for females appear to be higher than the pulse rates for males. That's true. D. Do I have any nurses in here? Because I read somewhere too that it depends on which arm you take the pulse rate from, or not the pulse rate, your blood pressure, which you can also kind of get beats per minute when they do that test. So you also have to be careful which arm you take these measurements from, because that can also be different. Okay, 5 is exactly the same. So I'm just going to say C steps from problem 4. So you would again use the computer. And this one is, you go to a bank and you look at the waiting times for if they have just one line where everybody gets in line, or if they have individual lines, so you can kind of, the grocery store, you can pick which line to go into. 2, 3, 4, 5, 6, 7, 8, 9, 10. N is 10, so a little bit smaller, but I would still use the computer. See problem 4 for the computer steps. And just load it up in StatCrunch and have it crunch it out. And you'll get the following numbers. For a single line, the mean waiting time is 7.17 minutes. The median for single line is 7.2, very close to each other. Then for the individual lines, so multiple lines you can choose from, you'll get 7.17, and the median is 7.2. Now, these two numbers are connected. This is single line versus individual lines, multiple lines. And then these two numbers are connected because this is single line median versus individual line median. And what do you notice about these two sets of numbers? They're the exact same. So this says there's absolutely no difference in which line you pick. But then you look at the actual numbers. Single line, 6, 6, 6, 6, 7, 7, 7, 7, 7, 7. Almost no difference in those values. 6 minutes, 7 minutes. Look at individual lines. 4, 5, 6, 6, 6, 7, 7, 8, 9, almost 10. There's a 4 minute to 10 minute, there's a 6 minute difference in those values. And this is what we're going to learn in section 2, is that these two lines might have the exact same centers, but this one's going to be a lot wider. The normal curve is going to be wider than this one, which is harder to plan for, right? If I go to the bank and I know I only have 8 minutes, that's all I have because I've got to get back to work. Which line am I going in? Single line. This one, I might be sitting there for 10 minutes and I can't afford that. So let's see. Determine whether there is a difference between the two data sets that is not apparent from a comparison of the measures of center. The times for customers in a single line are much more varied than the times for customers in individual lines. That says the opposite of what's true. The times for customers and individual lines are much more varied than the lines for, yep, B's right. So much more varied is what we call that. Okay, we just have 2 more math ones, and then the last 3 are just vocab word test. But these next 2 are hard. So let's really take our time and make sure that everyone's on board with these. So these are going to be, the next 2 problems are examples of weighted means. And it was the most complicated formula I wrote down today. So let's kind of see how it works. And oh, by the way, the computer will not do these for you. So these you have to do by hand. Okay. And in fact, this one's even more complicated than the weighted mean that I showed you. So this gives us a frequency distribution. So it says this is the low temperatures in degrees Fahrenheit for different days. So we had 3 days where the low was between 40 and 44, 7 days where the low is between 45 and 49, etc. Now the challenge to this one is the weighted mean calculation said take each of your x values times its weight. But in this problem I have 2 x values, a 40, a 44, then a 45. Let me just cut to the chase. What you're going to do on a problem like this is find the midpoint. Does anyone remember what the midpoint was? This goes back to when we first introduced a frequency table. The midpoint was the number in between the 2 numbers. So the number in between 40 and 44 is 42. The number in between 45 and 49 is 47. And then they go up by 5. So the pattern is they go up by 5. So 52, 57, 62. So in this one, what we do is we take each midpoint times its frequency. So the mean, x bar, is going to equal 40, you'll see the pattern real quick, 42 times 3 plus 47 times 7 plus 52 times 12. These frequencies are like the weights. This says 12 of the days were 52 degrees Fahrenheit. So I want to weight that heavy because it was the most frequent temperature we saw. Plus 57 times 4 plus the last one, 62 times 2. Anyone get lost on how I got that? Midpoint, so each of these numbers times its frequency. Now you just divide by the frequencies. So you divide by this 3 plus this 7 plus this 12 plus the 4 plus the 2. So the denominator is just add up all your weights or your frequencies. And if you do this correctly, and I encourage you to practice this because it's a little tricky on a calculator to do multiplications and then intersperse additions. But if you're patient and you add this up correctly, you'll get 1431 on top, 28 on bottom, which divides to be 51.107. And they want to the nearest tenth, which is right here. This number is less than 5, so we'll dump those two, call it 51.1. Okay, now they say, notice this is an estimate because I have 12 numbers in my list that are between 50 and 54. I estimated that they were all equal to 52 degrees. But that's probably not true. There might have been a couple 50s, a 51, a couple 53s. I don't know. I can't see the data, so I'm just going to assume all 12 were 52 exactly. So what they tell us is, hey, they took the original 28 numbers, added them all up, and divided by 28, and they got the mean to be 51.4. So the actual was 51.4. Our estimate was 51.1. Are those pretty close? I would say very close, right? They're only 0.3 of a degree off. So how are they close? We would say the computed mean is close. So these not closes are gone to the actual mean because the difference between the means is less than 5% of the actual mean. Now, I have to show you how to calculate that, though. So they just did a percent difference calculation. Percent difference, and you'll use this in your science courses a lot, is equal to the actual number minus the estimate divided by the actual times 100%. For our problem, the actual was 51.4. So we had 51.4. Our estimate was 51.1 divided by 51.4 times 100%. If you do this calculation for this problem, you will get the percent difference is equal to 0.58%, which is much smaller than 5%. So clearly this is a problem where this math works out just fine. Questions on that one? If you got lost or something, I would refer back to this video, right? So the video will be there. You can slow me down, pause me. That way, if there's something fuzzy, you can clear it up. But let's keep moving because we're starting to run out of time. So 7 is the last math one in this section, and it's probably the most useful because it's a GPA calculation. So how do you calculate GPA? You should be able to do this for yourself so that you can keep track of where you're headed. So they're using a 4-point system. So A gets 4, B gets 3 points, C is 2, and a D is 1, and 0 points for an F. What is the GPA of a student who gets an A in a 2-credit course, B in a 3, and etc.? So for GPA, it's another weighted mean. It's equal to, you take your points times your credits divided by, so this is a total, so you have to do this a bunch of times. And then you divide by the total credits. You'll see the pattern. So it says they get an A, which is 4 points, so that would be 4 in a 2-credit course, so that'd be 4 times 2. Plus, they get a B in each of 2 3-credit. So a B is 3 points, and they had 3 credits, but they did that twice. So there's 2 B's times 3's. So this was an A, this is a B here, this is another B. Then they got a C in a 3-credit course. A C is 2 points. So that's your C, times it was 3 credits. And then they got a D in a 2-credit course. So plus D, which is 1 in a 2-credit. So notice, each grade converted to its corresponding point value, then each credit hour. Now we divide by the credit hours. So the 2 plus this 3. So I just like to line them up, plus this 3, plus this 3, plus this 2. And if we do this, they have 34 points divided by 13 total credits, which is a GPA of 2.615. And if we round to the nearest tenth, that's this digit. This 1 says chop off the rest, 2.6. Good there? Okay. A value at the center or middle of a data set is a measure of center. That's been the whole topic today. Which of the following is not a characteristic of the mean? Which of the following is not a characteristic of the mean? The mean is relatively reliable. Yeah, the mean is very reliable. It's used all the time. The mean is called the average by statisticians. So statisticians hate this word. I don't know why. Well, I do know why, but I don't know if I agree because everyone else uses it. Average, they say, is a description of a, it's been kind of hijacked by people to explain things that are just a description of people instead of a mathematical statement. The mean takes every data value into account. Yes. So you add up all the numbers, which is all of them, divide by how many you have. The mean is sensitive to outliers. We will learn this, but this is also true. So all of them are true except for this one. Last question. Which of the following is always true? The mean and median should be used to identify the shape of the distribution. We don't use the mean and median to identify shape. We use it to identify the center. In a symmetric and bell-shaped distribution, the mean, median, and mode are the same. That is true. So if your bell shape is perfectly symmetric, all these measures of center will be exactly the same number. Data skewed to the right have a longer left tail than right tail. That says the opposite. For skewed data, the mode is farther out in the longer tail than the median. That's not true either. Okay, if there's no questions, that is it for 3.1.